Welcome back. Today we're going to be doing a related rates problem about a spherical balloon. A spherical balloon is being inflated at a rate of 10 cubic centimeters per second. How fast is the radius increasing when the radius is 5 centimeters? Okay, so first I'm going to write down what is given. So we know that the increasing rate is 10 cubic centimeters per second. So that means that dv over dt is equal to 10, right? Because dv over dt is the rate of change of the volume with respect to the time, and that is essentially what they're telling us here with the 10. Then we have that r, the radius, is 5, because that's given right here in the question. And so basically, what we need to find is dr over dt, so what is the rate of change with respect to time, when r is equal to 5. Essentially, that's what we're wanting to find. Okay, so how are we going to do this? Well, we first need to use the volume formula for a sphere. So as a reminder, the volume of a sphere is 4 over 3 pi r cubed. And then we're going to differentiate it with respect to the time. So dv over dt is equal to 4 pi r squared, right? Because that's our derivative. And then times dr dt, like that. And then we're going to plug in the value we know, which is essentially that the radius would be equal to 5, and also that dv over dt is 10. So I'm going to take this and I'm going to replace this with 10, then I'm going to take this and replace with 5. So 10 is equal to 4 pi 5 squared times dr dt. And then we just solve for dr dt. So over here, we're going to get 5 squared is 25 times 4 is 100. So we're going to get 10 is equal to 100 pi times dr dt. Therefore, dr dt is equal to 10 over 100 pi. And that is going to be, if we divide both by 10, we get 1 over 10 pi. And so that is our final answer, that 1 over 10 pi centimeters per second is our related rate. And so that is the answer I'm going to pick, the first answer there. Now, as always, if you have any questions, feel free to leave those in the comment section, and I'll see you for the next one.